Okay, in this lesson, we're going to learn about multiplying and dividing monomials. Before we get started, however, we need to define what a monomial is. So a monomial is essentially an algebraic expression consisting of one term. Okay, so what does that mean? Let me write this down. Monomial, examples. The number 2 is a monomial. The letter y, or the variable, is a monomial. 3 to the 4th power is a monomial. 6y is also a monomial. Okay, so hopefully those examples will help you to understand what a monomial is. And as I said before, it is an algebraic expression consisting of one term. Okay, so this is one term, this is one term, this is one term, this is one term. Okay, now I'm jumping ahead here, but if you take a monomial 2 and then another monomial y and add them together, that is now a polynomial. Okay, you may have heard that word before, and we will cover that at a later lesson, but I just wanted to help you differentiate between a monomial and a polynomial. So let me define a monomial again. It's an algebraic expression consisting of one term. Okay, so let's talk about multiplying monomials. Okay, so let's say you've got 2 to the 3rd power times 2 to the 2nd power. Okay, that is the same as 2 times 2 times 2 times 2 times 2. Okay, so we have 3 of them here, which is your 2 to the 3rd, and then you've got 2 of these here, which is your 2 to the 2nd. Okay, what does that equal? It equals 2 to the what power? How many 2's are there? 1, 2, 3, 4, 5. 2 to the 5th power. Okay, now take a look at this answer and compare that to what we started with right here. What do you notice related to the exponents? The exponents 3 and the exponents 2. 3 and 2. Okay, and how does that relate to 5? Hopefully you see a pattern and you realize that 3 plus 2 is equal to 5, right? So what that means is, if I were to write this problem again, 2 to the 3rd times 2 to the 2nd, that is equal to 2 to the 3 plus 2, which is equal to 2 to the 5th. Okay? Now, let's use another example. Let's use a base 3 and say 3 to the 2nd power times 3 to the 4th power. What does that equal to? Okay? If we follow the previous pattern of adding the exponents, because we're multiplying monomials, right? This is a monomial, this is a monomial. When you multiply them together, you add the exponents. So now it's 3 to the 2 plus 4 power, which is equal to 3 to the 6th power. Okay, so let's test that out. This is equal to 3 times 3. Okay, that's a set of 2 times 3 times 3 times 3 times 3. And there are 4 of them. And that is equal to 3 to the 1, 2, 3, 4, 5, 6 to the 6th power. Okay? So let's look at what happens when we divide monomials. Let's use a base 5 and say 5 to the 5th power, okay, divided by 5 to the 2nd power. Well, that is equal to, the numerator would be 5 times 5 times 5 times 5 times 5. 5 of them. And the denominator would be 5 times 5. Okay, we can cancel some numbers out, right? So this one cancels this out, this one cancels that out. Now we're left with 5 to the, how many? 1, 2, 3. 5 to the 3rd power. Okay, so now let's take a look at the exponents and ask yourself, what relationship do we see between this one, and this one? Hopefully you see it. And what we find that is that 5 right here minus the 2 gives us the 3. Okay, so in other words, 5 to the 5th power over 5 to the 2nd power is equal to 5 to the 5 minus 2. And that is equal to 5 to the 3rd power. So let's try this with a variable. Let's say the variable is y to the 4th power divided by y to the 3rd power. Okay? Now, according to the previous example, this should be y to the 4 minus 3, which is equal to y to the 1st power, or just y. Okay? So let's test this out. This is equal to y times y times y times y for the numerator, and then the denominator is y times y times y. Okay, there are 3 of them. So this cancels out, this cancels out, this cancels out, and now you're just left with a y. Okay, so let's take a look at another example. In the previous example, we had a monomial in the numerator whose power was greater than the power of the monomial in the denominator. Okay, I know that was a handful and you probably didn't quite catch what I meant by that. But let's suppose in this example we have the number 6 to the 2nd power divided by 6 to the 5th power. Okay, this is a little different because in the past, as I was saying earlier, that 6 to the 5th power would typically be in the numerator, right? The exponent 5 would be larger than 6 to the 6 to the 2nd power, or 6 squared. So 5 would be greater than 2, but now we've got it flipped around. We can still solve this problem, right? Because this is the same as 6 times 6 over 6 times 6 times 6 times 6 times 6. Okay, so now you cancel this out and you cancel this out, and you're left with 1 over 6 to the 3rd power. Okay, now if I wanted to not express this as a fraction, you would then write this as this would equal 6 to the negative 3rd power. Okay, you see that? 1 over 6 to the positive 3 power is the same as 6 to the negative 3 power. Okay, so let's test this out. We said that 6 to the 2nd power over 6 to the 5th power, okay, is equal to 6 to the 2 minus 5. and that is the same as 6, 2, and negative 3 power. See that? They're identical. So to summarize, when you are multiplying monomials, you add the exponents. Okay? When you're multiplying monomials, you add the exponents. When you are dividing monomials, you take the difference, or you subtract the latter from the former. Okay? So in other words, I'm going to express this in algebraic terms. A to the x power times b to the y power. Okay, this is multiplying monomials, right? Because a to the x is one monomial, b to the y is another monomial. When you multiply that together, I'm sorry, let me correct myself here. Okay. So a to the x is one monomial, a to the y is another monomial, assuming that the bases are the same, right? So the letter a is your base. Then you add the exponents. However, if you are dividing monomials with the same base, then the answer would be the base to the power of x minus y. So these are two equations worth remembering, okay? But again, you don't have to memorize it if you understand the concept that I just taught, okay? Again, if you don't remember the equation, here's how you figure it out. Let's use another example. 2 to the second power times 2 to the third power is equal to 2 times 2 times 2 times 2 times 2. And that is equal to 2 to the fifth. Okay? 1, 2, 3, 4, 5. And then when you're dividing, let's say you have 2 to the third divided by 2 to the second. That is equal to 2 times 2 times 2 divided by 2 times 2. Cancel these out, and you're left with 2. Okay? Hopefully that makes sense. If any of this was a little confusing, please go back and listen to this recording again. Thank you.